quality education. Expanding access to learning. Serving learners' learning needs. Tackling challenges of the present time. Supporting every learner's dream. Reaching young Tagameños where they are today. From the music capital of the Philippines, advancing in the challenge of distance learning. Bringing you quality education straight to your home. Plug yourself in. This is DepEd TV. Tara na!
Hello, our dear learners! It's time for a new and digital way of learning the world of mathematics. I am so glad to be part of your journey as you discover new lessons through television. Airing from Tuasan Eskwela TV, I am your teacher on air, Teacher LG de la Serna from Jose Tuasan Jr. Memorial National High School in the service of DepEd Tagum City. Aiming to continue education amidst the challenges brought by the pandemic. Together, we will master our competencies while staying at home. So what are you waiting for? Let's go! Let us learn while having fun. Indeed, expect a meaningful learning. In this session, you will learn to solve problems on circles, Module 6 of Quarter 2. The most essential learning competencies that will be discussed in this video is to solve problems on circles with competency code M10GE-2F-2. Let us learn starting with our lesson objective, that is to solve non-routine problems on A. Chords, arcs, central angles. Letter B, arcs and inscribed angles. Letter C, tangent and secant of a circle. Letter D, tangent and secant segments of a circle. Before we delve deeper to our lesson, let us try answering the pre-test, which will measure your previous knowledge about the topic. Please solve for what is asked in each item and choose the answer among the choices. You will be given 5 seconds to answer. And when you hear this sound, then time is up. Are you ready? Let's begin! Reminder, please have with you your Mathematics 10 Quarter 2 Module 6, a pen and a paper. Number 1. Find the value of x and measure of angle PSM. Refer to the figure. Your time starts now. The answer is letter A. X equals 9 and a measure of angle PSM equals 40. Number 2. Find the measure of arc MN. Refer to the figure. Your time starts now. Yes, the answer is letter C. You got it right. 104 degrees. Number 3. Find the value of x and the measure of angle CGF. Refer to the figure. Your time starts now. The answer is letter D. X equals 8. A measure of angle CGF equals 115 degrees. Number 4. Find the measure of segment MO. Refer to the figure. Your time starts now. The answer is letter D, 4 units. Number 5. Find the measure of segment YC and segment ZB. Refer to the figure. Your time starts now. The answer is letter B. Segment YC equals 35 and segment ZB equals 26. How's your score? Congratulations for performing well. It's time to move forward. This time, let us study how to solve non-routine problems on circles. Remember that in the previous modules, the different theorems on circles were introduced. We will use those theorems in solving the following problems on circles. Take a look at this illustrative example, number 1. What is the measure of angle AOE and angle EOD? Since AD is a straight line, then the measure of angle AOD is 180 degrees. Then angle AOE plus angle EOD equals 180 degrees. Input the given expressions, that is quantity x plus 134 degrees plus quantity x plus 54 degrees equals 180 degrees. Group and combine like terms, we get 2x plus 188 degrees equals 180 degrees. Using subtraction property of equality, subtract 188 to both sides of the equation. Simplify, we get 2x equals 180 degrees minus 188 degrees. Simplify further, subtract 188 from 180. We get 2x equals negative 8 degrees. Lastly, divide both sides of the equation with 2. We get x equals negative 8 divided by 2. Therefore, x is equal to negative 4. To find angle AOE, which is equal to x plus 134, substitute negative 4 to x. So we get negative 4 plus 134 equals 130 degrees. Likewise, to find angle EOD, which is equal to x plus 54, substitute negative 4 to x. So we get negative 4 plus 54 equals 50 degrees. Therefore, angle AOE is 130 degrees and angle EOD is 50 degrees. Illustrative example number 2. Find the value of x. Recall that the degree measure of a minor arc is the measure of the central angle which intercepts the arc. Input the given expressions, that is quantity 10x plus 65 degrees equals quantity 5x plus 85 degrees. Group together like terms, we get 10x minus 5x equals 85 minus 65. Combine like terms, we get 5x equals 20. Lastly, divide both sides of the equation with 5. We get x equals 20 divided by 5. Therefore, x is equal to 4. Illustrative example number 3. Find the value of x. Recall that if an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of its intercepted arc, or the measure of the intercepted arc is twice the measure of the inscribed angle. In this case, twice the measure of inscribed angle is equal to the measure of intercepted arc. To find x, multiply 2 with quantity 2x plus 1 degree. We get 4x plus 2 equals 150. Using subtraction property of equality, subtract 2 to both sides of the equation. We get 4x equals 150 minus 2. Simplify, we get 4x equals 148. Lastly, divide both sides of the equation with 4. We get x equals 148 divided by 4. Therefore, x is equal to 37. Illustrative example number 4. Find the value of x and the measure of arc MA. Recall that if two inscribed angles of a circle or congruent circles intersect, congruent arcs are the same arc, then the angles are congruent. In this case, measure of inscribed angle MHA is equal to the measure of inscribed angle MIA. First thing to do is to find x. Input the given expressions, that is quantity 17x minus 8 degrees equals quantity 21x minus 40 degrees. And group together like terms, we get 17x minus 21x equals negative 40 plus 8. Then combine like terms, we get negative 4x equals negative 32. Lastly, divide both sides of the equation with negative 4. We get x equals negative 32 divided by negative 4. Therefore, x is equal to 8. Second, find the measure of either of the two inscribed angles MHA or MIA. This time we use a measure of inscribed angle MHA, which is equal to the expression 17x minus 8. Input 8 to x, then we have 17 multiplied to 8 minus 8. Our measure of an angle MHA equals 136 minus 8. Thus, the measure of angle MHA is equal to 128 degrees. Finally, find the measure of arc MA, which is equal to twice the measure of an inscribed angle MHA. Input the measure of inscribed angle MHA, which is equal to 128 degrees. Therefore, the measure of arc MA is equal to 256 degrees. Illustrative example number 5. Find the value of x and the measure of angle ABC. Recall that if a secant and a tangent intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the positive difference of the measures of the intersected arcs. In this case, measure of angle ABC equals 1/2 the positive difference of the measures of the intersected arc AC and arc BC. Input the given expressions and values. That is quantity 4x plus 7 degrees equals 1/2 the positive difference of 160 degrees minus quantity 5x plus 3 degrees. Simplified, we get 4x plus 7 equals 1/2 the positive difference of 160 minus 5x minus 3. Multiply both sides with 2, we get 2 times the quantity of 4x plus 7 equals 157 minus 5x. Multiply 2 with quantity 4x plus 7, we get 8x plus 14 equals 157 minus 5x. Group like terms, we get 8x plus 5x equals 157 minus 14. Now, combine like terms, we get 8x plus 5x equals 157 minus 14. Then simplify, we get 13x equals 143. Divide both sides with 13, we get x equals 143 divided by 13. Therefore, x is equal to 11. Illustrative example number 6. Find the value of x and the measure of angle KML. Recall that if 2 seconds intersect in the interior of a circle, then the measure of an angle formed is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical. In this case, measure of angle KML equals 1/2 the sum of the measures of the arcs KL and ON intercepted by the angle and its vertical. Input the given expressions and values. That is 6x equals 1/2 multiplied to the sum of 53 and quantity 5x plus 3. Simplify, we get 6x equals 1/2 multiplied to quantity 56 plus 5x. Then multiply both sides with 2, we get 2 multiplied to 6 equals 56 plus 5x. Simplify again, we get 12x equals 56 plus 5x. Group like terms, we get 12x minus 5x equals 56. Then combine like terms, we get 7x equals 56. Divide both sides with 7, we get x equals 56 divided by 7. Therefore, x is equal to 8. To find angle KML, which is equal to the expression 6x, input 8 for x. Therefore, angle KML is equal to 48. Illustrative example number 7. Find the length of the unknown segment. Recall that if 2 chords of a circle intersect, then the product of the measures of the segments of one chord is equal to the product of the measures of the segments of the other chord. In this case, the product of the measures of segments AC and CD is equal to the product of the measures of the segments EC and CB. Input the given expressions and values. That is 6x multiplied to 8 equals quantity of 5x plus 1 multiplied to 9. Simplify, multiply 6x and 8 and multiply 9 to each term of quantity 5x plus 1. So we get 48x equals 45x plus 9. Group together like terms, we get 48x minus 45x equals 9. Then combine like terms, we get 3x equals 9. Divide both sides with 3, we get x equals 9 divided by 3. Therefore, x is equal to 3. Using x equals to 3, find the measure of segment AC, which is equal to the expression 6x. Input 3, 4x. Therefore, segment AC is equal to 18. Using the same value of x, find the measure of segment EC, which is equal to the expression 5x plus 1. Input 3 for x, we get 5 times plus 1. Therefore, segment EC is equal to 16. Illustrative example number 8. Find the length of the unknown segment. Recall that if a tangent segment and a secant segment are drawn to a circle from an exterior point, then the square of the length of the tangent segment is equal to the product of the lengths of the secant segment and its external secant segment. In this case, the square of the length of the tangent segment MN is equal to the product of the lengths of the secant segment MK and its external secant segment ML. Input the given expressions and values. That is, quantity x plus 3 raised to 2 is equal to the product of quantity x minus 3 plus 16 and quantity x minus 3. Expand the left part of the equation and simplify the right part of the equation. So we get x raised to 2 plus 6 plus 9 equals the product of x plus 13 and x minus 3. Grouped together like terms, we get x squared minus x squared plus 6x minus 10x equals negative 39 minus 9. Then combine like terms, we get negative 4x equals a negative 48. Divide both sides with 4, we get x equals a negative 48 divided by negative 4, therefore x is equal to 12. Using x equals to 12, find the measure of external second segment ML, which is equal to the expression x minus 3. Input 12 for x, we get 12 minus 3. Therefore, external second segment ML is equal to 9. Using the same value of x, find the measure of tangent segment MN, which is equal to the expression x plus 3. Input 12 for x, we get 12 plus 3. Therefore, segment MN is equal to 15. Always remember, to solve non-routine problems in circles, the following steps may help you. Now that you have understood and can now solve non-routine problems in circles, let us practice. It's your turn to solve the following problems on circles. You will be given 20 seconds for every problem. When you hear this sound, that means time is up. How's your score? Very good, students! I hope that you have learned great lessons today. May these learnings help you appreciate and apply mathematics in your daily life. As a point of reflection, the importance of knowing and understanding the concepts related to circles, such as tangent, secant, exterior second segment, and arc, facilitate finding solutions to real-life problems and making decisions, may it be in architecture, science, construction, transportation, and even in video games. That ends our lesson for today. This has been your teacher on air, Teacher LG de la Serna. See you in the next episode only here at Tuasan Eskwela TV.